Okay, welcome to this video lecture covering one problem in February contest. That's a message relay. Let's go to the problem. So in this problem we have up to 1,000 cows. They are communicating with each other, they are relaying messages. I will let you guys read through the details. The main thing is for each cow I, the value of f of I specifies which is the index of the cow it's going to forward message. So f is forward, okay? The cow I is forwarding to the f of I, okay? The next cow it's going to send that message to, okay? If the f of I is 0, then cow I does not forward messages basically. So here is the data. So number of cows n, basically 5 is the number of cows, and then this specifies the f of I. So okay, let's see. Then we have to find I was hoping to just explain using the picture, so let's go to that picture. So here is the data. So that's the count, right? So that's the count, how many cows, right? So you have cow 1, cow 2, cow 3, cow 4, cow 5. Okay, so cow 1 does not forward anywhere, you can see, because it's 0, right? So cow 2 forwards to 4, cow 3 forwards to 1, cow 4 forwards to 5, cow 5 forwards to 4. Okay, so the question is which are the loopy cows and which are the non-loopy cows, right? So loopy versus non-loopy. So once you draw the picture, it's pretty clear, right? So this guy's 2, 4, 5 are stuck in a loop. Remember, 2 itself is not part of the loop, but its messages go to the loop and the really messages do get stuck, right? So the non-loopy, that's the non-loopy, right? So the loopy is this, we kind of leave it as the red. So basically you are going to count just 1 and 3 basically, okay? So this is output is going to be 2. Because there are only 2 nodes that are not involved with your loop. So even though cow 2 is not in the loop, it is feeding to the loop, so the message gets stuck here, okay? So it's not counted, only 1 and 3 we need to count. By the way, anytime during the discussion, if you want to stop it and try it on your own, please do so. You know, more you can try it on your own, spend some time before listening to the full solution. That's always good, you know, exercising the brain. So we already talked about loopy versus non-loopy, okay? So cows that are not forwarding messages are clearly non-loopy, right? So this is the case where f of I is equal to 0. So then the cows that send messages to that the previous line cows, you know, the cows which are f of I is 0. So cows that are sending messages to those cows are non-loopy too, right? So similarly the next level, so on, okay? So idea is basically, when you go back to the picture, we can potentially start with this non-loopy cows where f of I is equal to 0, right? So this is really a special cow, right? Because it's f of I is equal to 0. So we can start we can start with those cows and work backwards, right? So we can see how many cows are feeding to that, and then how many cows are going to feed to the next level cows, so on. Okay. Okay. So that, at least that's the idea, right? So can a cow be both loopy and non-loopy? For example, 3 was feeding to 1, and let's say 3 was feeding also to 2, then forwarding to 2, then the 3 will become both loopy and non-loopy, right? So here, for example, this way, I guess, if this was allowed, right, then 3 is in trouble, because now it forwards messages to 1, it also forwards messages to 2, so then that will be a non-loopy, also loopy. But good thing is that's not possible, right? Because f of I is just one number. So f of 3 is, what do we say, 1, right? That's only one number. So you cannot be part of your loop one side and the other side non-loopy area portion, you know, so that's not possible. So the good thing is each cow is sending out message only to one another cow, right? So the forward will not create the loopy and versus non-loopy both conditions. So because it's not forwarding 2 cows, right? So it's really part of just one direction, right? So okay, but each cow can receive messages from multiple cows. That's allowed, right? Because multiple cows can forward the message to a specific cow, right? For example, let's go back to this picture. So right here, 4 is a good example. Cow 4, you can see message is coming from 2 and message is coming from 5 as well. So cow 4 receives message from multiple cows. Okay, cows, nodes, everything is same here. Okay, so nodes 2 and node 5, nodes 2 and 5 both forward messages to 4. Okay, so we can, multiple cows can send messages to each cow, but each cow cannot send multiple messages out. Okay, multiple forward is not allowed. Okay, so so the brute force algorithm, we already kind of talked about the algorithm, right? You start with the kind of sync cows, you know, sync cows meaning the ones that don't forward, right? So the wherever the f of I equal to 0, so those cows, and work backwards, right? So how do you work backwards? Well, brute force algorithm would be, for each cow with f of I equal to 0, we invoke a exploration method, okay, to explore and keep counting all the levels, all the cows that are feeding to it, and the next level cows, so on. Okay, so I meant only one I here. So so basically, as soon as we invoke this count non-loopy, immediately we kind of increment a variable. I don't know what I called in the program, but anyway, so it's just a one variable. Let me see what I called, just to keep the confusion to the minimum. I simply called it no loop. Okay, close enough. So I called in the program no loop. Okay, don't get confused by these two terms. So okay, so that's what I used in the program. Okay. Okay, so then after incrementing, then we want to see how many cows are feeding to this cow, right? So we invoke the recursion, we kind of do a for loop, we can check which cows are really feeding to this cow, right? The cow we are under consideration, cow I, right? So this way we keep going, right? Keep digging in, keep going until some particular reach a cow which does not get any messages from anybody, right? So recursion keeps going down, meaning recursion keeps going nested, what do you call it? Recursion depth, right? It keeps digging in, right? It going to the multiple levels, keep going in until you find a node which does not get any messages from anybody. So then you backtrack, okay? Backtrack and go in the other direction. So what's a good picture? Maybe let's see, picture would be here it's a cow 1. So this picture is pretty easy actually. Cow 1 and cow 3, right? So cow 1 is where we start with, then the recursion reaches cow 3, right? So then it doesn't go anywhere else, see? So it counts here, and no loop becomes 1 here, and no loop becomes 2 here when you go, but there's nothing to go from 3, right? So you come back, the whole algorithm is over. So in general sense, right, generically you may have a really big network. So really big network, so there may be multiple cows with f of I equal to 0, right? There can be multiple cows, let's say multiple cows with f of I equal to 0, right? So then they may have get messages from several nodes like that. So that's how recursion algorithm will proceed. It will visit all these nodes, right? So then this guy may get a message from several others. You get the idea, right? So it goes on as far as it can go. So you basically count all these nodes. These are all non-loopy nodes, right? So because they are all really forwarding the messages upwards, right? So recursion tree diagram looks like this, right? So we start with this special nodes f of I equal to 0, all the top nodes, right? So then we are finding the next level nodes, so on, okay? So this is the kind of recursive diagram, recursive invocation diagram, invocations, I'll just say, okay? Okay, so that's okay, but something bothers me here. By the way, I worked on this problem when the contest was open, so I was a bit worried that this may not be efficient enough. So I was worried about its performance based on this algorithm, because there's within the recursion you're doing a for loop. So so while this algorithm will work, let's look into the code as well. So this is how I coded that algorithm. So it's pretty similar to what I wrote there. So you read all the values, and simply in a loop, if the forward of I is equal to 0, I invoked the non-loopy, count non-loopy, and count non-loopy does the checks whether forward is the cow index, and then invokes the non-loopy again. So it's exactly same as the algorithm I have shown. So I thought this recursion is problematic, time wise. It will work, but time wise it can be problematic. So then I went ahead and thought about how we can improve it. So this is a very inefficient operation. When you're going into recursion, at that time you're checking all the cows whether they are forwarding to I. So what can you do to kind of improve that? Well, improve. One thought is basically f of I stores the receiver, receiver from the current cow, or forward f is forward, right? We can use another array, sender, to store the sender basically for the I who is sending to I, basically, right? So if we can do that, when you know I, we know s of I right away, because if we store it that way, then we know the s of I right away. So then you don't need to do a for loop. You can simply count those senders alone. but we know that each cow can have several senders. What do we mean by that? We can have like this. So here, when you do s of I, for this guy, when you do s of I, it has multiple values. See? So it's not just one integer, it can have multiple values. Whereas we didn't have that problem when you have forward, right? I and forward of I, because I is going to forward only one cow, so that was not the problem. So here, multiple senders are there, so we need a list instead of just one number. So this is why integer array f of I was here. It cannot be integer array, instead it's array of lists. You can create a list for each cow and grow it as needed, the size, but instead we can use the C++ vector or Java, some generic, I believe, array list or something in Java. So you can use that to get it done quickly. That's exactly what I did. So maybe one of you can kind of do this in the Java too. Okay, and share it in Piazza. So back to my program. So here, let's see how I implemented. So relay2.cpp. So how I implemented is, you can see after reading the number of cows, I read the forward value. So for I f of I, so then I really store, I push I to the f of I list. So how do I show this? Okay, let's see. Let's go back to this picture, right? So what I stored is that now we have S array. So S is a list, right? So senders list. So we have so I'm maintaining the list, right? So for the cow 1, the cow 1 is not forwarding to anybody, so that's not a problem. So the cow 2 is sending to 4, so 4, the sender is 2. Okay, so right, so for cow 4, sender is 2. Okay, so cow 2 is forwarding to 1, right? Oh, I'm sorry, cow 3 is forwarding to 1, so there is a 3 here. Okay, so 3 is forwarding to 1, 4 is forwarding to 5, so 5 is the receiver, 4 is the sender. Cow 5 is sending to 4. Okay, so effectively this is how the lists look. So this is here is an empty list. I guess we can call it empty list. As the cow, as you read the data, we form this list. Okay, so once these lists are formed, now it's pretty easy. Now the cow 1 is the cow 1 is the one where's the f of I equal to 0. So how do we do that here? How did I implement? Directly counter non-loopy. Okay, what check did I make? Oh, okay. Oh, okay. So I'm maintaining also a list. I am also maintaining the list of cows that are forwarding to 0. Okay, so I'm also maintaining that list, so that picture looks really 0. Okay, so the cow 0, we are pretending there's a cow 0 in a sense. So then who is forwarding to 0? Cow 1. Okay, so we start from here. we start from 0 and we count 1, and then we go to the ones list, twos list, so on. So you can see with this this data structure, list of array of lists becomes a lot easier, right? So you basically take the cows that are sending the message to 0. Effectively they're not sending, so but that's a list, right? That's a starting list we go with. For each of that number we go to the corresponding list and add that cows, count those cows, and look for to that list too. So 3 for example, nobody is sending to 3, see, so right there it stops. Okay, so the key thing is that for loop, you are not searching the whole array of cows. Instead, everywhere, see here, primarily here within the recursion, we are going through the only list, basically the sender lists, right? Sender list for that cow. Sender list for the cow is lists of cow index, so yeah, there are some pre-inbuilt functions like size and all that, and you can access it like a two-dimensional array. You can see here. So this is that cow's list and ith item in that list. Okay, that's a good thing about C++. So arrays operate is overloaded with several things, several structures. So vector is one of them. Okay, so again, go down here. Let's see, we are reading the forward f of I, so then we are storing in a sender structure. Okay, so we are saying the I is sending the message to forward, right? FWD cow, so that's how we are storing. So we are sender list cow, sender list structure, right? So then we start with this counting. So cow index 0, for cow index 0 sender list is where we start with, because for them basically f of I equal to 0, right? So you start the counting there, and for each of that cow, then recursively that are feeding to that cow, basically recursively we are using the list, not the full f of I structure, f of I array. Okay, instead of the previous version, here is the previous version where we were searching throughout the array of the cows. So here we are simply considering that small list basically. Okay, so we are counting for that, invoking recursion for each of that cows. Okay, so hopefully you got the idea, and I will attach all the files as well. Okay, thank you.